Recently, we learned that integers are 32 bits and can only have integer values, and doubles are 64 bits and can have decimal values. And we learned that with integer division, I can only get an integer answer, but if something is a double, I can get a decimal answer. But integers can only hold integers can only hold integers, and then doubles, if you assign an int to it, will make it a double. So that's a ton of stuff going on. So my point in saying all that is, what if I need something to act like an integer, something to act like a double? How can I accomplish that? And that is through typecasting. It's when we convert from one type to another. So you can promote an int to a double to get the exact division, or you can truncate. Remember, that just means drop off the decimal. We can truncate a double to become an integer, okay? And so to do that, you basically, in parentheses, you specify what you want to convert it to. If you want to convert it to an int, you would say int. If you want to convert it to a double, you would say double. And then right after it, you say what you're converting it to. So for example, here, I want to convert this 19 to a double. And so you convert it by putting a 0.0. And by converting this to a double, now when I do 19.0 divided by 5, I am allowed to get a decimal answer. And this answer is going to be stored in result. So at the end of this statement, result is going to be 3.8. So then if I come down to this line to find out result 2, which is going to be an int, I want to cast our result, which we just got was 3.8. I want to cast this to an int. And the way we cast is we just drop the decimal part. So basically result 2 is going to store 3. We truncated it. Now in Unit 2, we're going to learn about the math class, but I'm going to show you how this would work. So this is basically telling you to take 10 and raise it to the power of 3, which we know is 1,000. But the way this function is actually written is it would make it a double value. And so if I want to be able to assign it to an int, I'm first going to have to cast it to an int. And remember, casting just means truncate the decimal, drop the decimal. And so this would get the 1,000. But this is an important step, and you'll see it in Unit 2, because without it, I would get a possible loss of precision error in my program. So it may not seem necessary now, but just trust me right now when I say that this is an important step that you would have to take. So realize that casting does have a fairly high precedence, but it only casts the item immediately next to it. So here, this double is only immediately next to the 1. So what happens is this is going to have a pretty high precedence and make it a 1.0. And then now I continue with order of operations. 1 and 2 are integers, so I can only get an integer. So 1.0 plus 0 is going to be 1.0. And so this is going to end up storing a 1.0. In this expression, double is immediately touching the 1, so I'm going to make that a 1.0 before continuing on with my order of operations. 1.0, because it's a decimal, I can get a decimal answer here. So this is going to be the result of 1 plus 0.5, which will be 1.5. And so y is going to end up storing 1.5. And then here, this double is touching the parentheses, so before I can cast something to a double, I first have to calculate this. Now 1 divided by 2, because both of those are integers, is a 0, not 0.5. But then I'm going to cast it to a double, which will just add in a 0.0. So then I'm going to do 1 plus 0.0, which is just going to be 1.0. Probably the person writing this statement did not intend for that to happen, but it is something that's common, that you're casting too early or too late and you're not getting the right calculation, which is even more reason to make sure you're testing your program regularly. We can also use this for finding the average of 3 numbers. Now this is an important thing to be able to do, because remember, if I have integer values, then when I do integer division, I can only get an integer answer. And so if you're not careful, then you will end up getting an incorrect average. So in these, some of these will calculate correctly or possibly not. So let's walk through it. Now, just for simplicity, notice all of these are adding A, B, and C. So I don't have to be redundant. Let's go ahead and add A, B, and C's values. All right, so we get 16. Just so that way I don't have to be redundant. So here I'm doing 16 divided by 3. Now notice this is an integer and this is an integer, which means I can only get an integer. So 16 divided by 3 is just going to be 5. But then if you notice, I'm storing it in a double. So guess what's going to happen? It's just going to add 0.0. So this adding the 0.0 is done when I'm storing it, not during the calculation part. Now let's be honest, this means that it was not calculated correctly. That's not the average of 5, 5, and 6. All right, let's look at what's happening here. So again, we said that this will be 16. So this double is going to take our 16 and it's going to cast it to a double. And then now we're going to divide by 3. Now notice here, one of my numbers is a double, which means that I am allowed to get a double answer. And it's going to take this 5.33 and it's going to assign it to average. And so that means that this is going to be calculated correctly. All right, what about here? So this is going to be 16 like we said. So I have 1.0 times 16 divided by 3. Now according to order of operations, I'm going to do multiplication first because left to right it came first. And then now I am doing decimal division, double division, so I will get what I expected to do for the average. So that one checked out. And then here, A plus B plus C was 16, and then this one does 16 divided by 3.0. So notice you don't have to cast in order to correctly find the average of 3 numbers. You just have to make sure that in your division, one or both of your numbers in your division are going to be decimals. Otherwise, you run the risk of incorrectly calculating it. Just because you're assigning something to a double variable doesn't mean that it automatically calculates correctly. It has to happen in the calculation process and not in the storage process. So over here you have to calculate it correctly, not when you're assigning it to the variable. Okay, so let's look at a couple more examples. All right, so here 1 divided by 3, integer and an integer result in an integer, and so this is just going to be a 0 because 3 doesn't go evenly into 1 at all. But then here, because at least one of my numbers is a decimal, I am allowed to get a decimal. And I don't know how many 3's I need to draw, so I'm just going to do that. Here, because one of my numbers is a decimal, I am allowed to get a decimal. And here, because one of my numbers is a decimal, I am allowed to get a decimal. So it doesn't matter how many are decimals as long as at least one of them is a decimal, and then you can get a decimal answer. Now let's talk about if I tried to do casting instead of making a number a decimal from the start. So here this double cast is applied to the 1, and then this is going to allow me to have a decimal answer. This cast is applied to the parentheses, so first I have to evaluate the parentheses. Now 1 and 3 are integers, so I can only get an integer, and then this double applies here, and all that does is add a 0.0. And then in this expression, the double is applied to the 3, so I'm going to be 1 divided by 3.0, and because now one of my numbers is a decimal. So my point in showing you all of these is you have to be very careful that when you're dividing, if you're going to need that decimal portion, there are lots of ways of accomplishing it, but you need to make sure that you're not doing something incorrect, like here where you're converting it to a decimal too late. Okay, let's look at another example. So let's look at what's happening here. Now, even though this says double over here, we do this after the fact. You always want to evaluate your right hand side first. So 5 divided by 2, those are integers, so I'm going to get a 2. And then now in the storage process, when I'm storing it and assigning it to A, that's when I make it a double, and that's when I put in the 0.0. All right, so in this example, I make my 5 a double and divide by 2, and I get 2.5, and then I assign that to B. And then here, the double is being applied to the parentheses, and so 5 divided by 2 is just going to be 2, and then I apply the casting to it, and then I assign it to my variable. So the only one that would have calculated 2.5 correctly, if that's what I needed it to calculate to, would have been here. The other ones, because in the division process neither was a decimal, all I ended up doing was putting 0.0 at the end, which is probably not what was intended. Now we can also use casting to round to the nearest integer, and the process will depend on if you have a positive or negative. Now again, right now it can seem kind of overwhelming because we haven't done a lot of programming, but these are skills that you could use in programs as we write them. If you want to round a positive number, you basically take that number and add 0.5 and then cast it to an int. So let's see how this would work. Let's compare how this would work with 2.1 versus 2.6. Now hopefully you can agree that this should round to 2 if we do this properly. So what are the steps? We take our number and we add 0.5, and then we take that result and we cast it to an int, which basically means you truncate, you drop the decimal, and we're left with this. Hopefully you can agree that 2 is what you would get if you rounded this. What about 2.6? All right, so according to this, I add 0.5. And then to cast it to an int, I truncate or drop the decimal portion, and I'm left with 3. And hopefully, again, you knew that 2.6 would round to 3. So this is a handy little algorithm that you can use, just an expression that will allow you to round positive numbers to their nearest integer value. Now what about negative numbers? Well, for negative numbers, you subtract 0.5, and let's see why. So let's start off with negative 2.1 and negative 2.6. All right. So if I subtract 0.5, I get negative 2.6, and then if I cast it to an int, I truncate or drop the decimal portion, and indeed negative 2.1 would round to negative 2. And then over here, if I subtract 0.5, and then I cast it to an int, I would truncate or drop the decimal portion. So again, these are handy little things for you to come back to once we get to that point. But just realize the power in casting and combining with